Hello, this video is on section 2.5, the first part of factoring binomials. We start with factoring difference of squares, and it talks about the factored form of the difference of squares. So a squared minus b squared can be factored to a plus b times a minus b, and we have a little shout out here of what that looks like. And then it also says a special note. The sum of squares does not factor. A squared plus b squared does not factor. And you can see it kind of says the same thing here. I just wanted to make it, bigger for you. So for example, when we talk about what are squares, because it has to be perfect squares, and then it has to have the difference. So it has to be a minus. So when I think about perfect squares for variables, I think of like x squared, y squared, a squared, x to the fourth power, things like that. And then as far as numbers go, perfect squares would be like 4, because 2 times 2 is 4, or 2 squared is 4. 3 squared is 9, 5 squared is 25. So this is what we mean by perfect squares. 49 is the perfect square to 7. 64, 81, this actually goes on forever. So you could continue that list if you wanted to, but there is one that students often forget about, and that's the number 1 itself, because 1 squared is 1. Okay, so we have the difference of squares, and we have to be able to factor them, and we know that it's the difference of squares when it meets the criteria of this has to be a perfect square, and the b has to be a perfect square, and it has to be a minus. So you can see we have this level 1 where we have x squared minus 25. X squared is a perfect square, and so is 25. So I'm going to basically have like the same binomial twice, but I'm going to have one positive, one negative. And that actually occurs like this whole time here. So I'm going to go ahead and draw this for you. All right. So in order to figure out what's going to go here, I get to do something really easy. I just take the square root of that number. Yeah, go ahead. So I get 5 and negative 5, right? Because the square root of 25 is 5. So 5 times 5 is 25. And then for number 2, I would do the square root of 1, which is 1. So I get x plus 1, x minus 1. And what's really cool is if you multiply this back out, so I just want to show you, if I multiply this back out, I would get x squared minus 5x plus 5x minus 25. And then the middle terms do cancel out, and I'm left with x squared minus 25, right? So you can always multiply it back out to check it. All right, so for number 3, I take the square root of 49. I get plus 7 and minus 7, or n minus 7 times n plus 7. And then the square root of 121 is 11. And then I have a few more. So I have a squared minus 81. So that would be a. And then the square root of 81 is 9 and 9, so positive, negative. And then I have x squared plus 25. Now, this really stumps students, and it's kind of funny because they'll come up with all sorts of fun answers. Like some people will say x plus 5 times x plus 5, but the problem with that is it would be x squared plus 5x plus 5x plus 25, which would give me x squared plus 10x plus 25, right? So that's like a common mistake that students make that makes me sad. But really, the problem is, and like I said at the beginning, that I tried to point out, that you're not able to factor a squared plus b squared. So actually, that is considered prime. And so anything that you tried to tell me here would be untrue if you multiplied it back together. All right, so now it's your turn to create your own difference of squares problem, and then create a sum of squares that is prime. All right, so I'll give you a moment to do that, and then I'll give you some examples. So you might want to pause the video and try that. Okay, to create your own difference of squares problem, you may have come up with x squared minus 49, or perhaps x squared minus 64, or even x squared minus 1. To create a sum of squares, maybe you came up with x squared plus 4, or x squared plus 16, or x squared plus 49. That would be an example of squares that would be prime. Okay, we're going to move on to the next level, which is exciting. And so that will start right now.
Hello, this video covers section 2.5, which is on factoring binomials, beginning with factoring the difference of squares. The factored form of the difference of squares, a squared minus b squared, is equal to a plus b times a minus b. You may remember that those are called conjugates, and when we multiply those together, the middle term cancels out. Now that we're factoring, we'll be doing the opposite of multiplication. An example that they like to show us is 25x squared minus 9y squared. 25x squared is a perfect square to 5x, and 9y squared is the perfect square of 3y. So therefore, we can factor 25x squared minus 9y squared as 5x plus 3y times 5x minus 3y. It's important to note that if a and b share no common factors other than 1, then the sum of squares, a squared plus b squared, is not factorable over the set of real numbers. So it is called the difference of squares, not the sum of squares. So we really have to pay attention to that sign there. Now I want to give you some basic examples before we start on the crazy ones that are offered on this paper. All right, so here are some examples of difference of squares. X squared minus 9. X squared minus 49. Penny. Sorry, I have a pug and she's really loud. X squared minus 4 and x squared minus 121, and also x squared minus 1. Now, if you look, I want you to notice a few things. First, all of these are subtractions, which is the difference. Second, these are all perfect squares. Of course, x squared is a perfect square to x. 9, the square to 9 is 3. 3 squared is 9. I bet you can think about 49, what number that would be. 4, 121, and 1. So I can actually factor these quite quickly. I know I'm going to have one positive and one negative, because when I multiply that together, the middle terms cancel out. So to figure out what goes in this position, I just need to do the square root of this number. So the square root of 9, as we've already discussed, is 3. So I can write this as x plus 3 times x minus 3. And if I could multiply it back out, I would see that the middle terms cancel. For number 2, I can write this as x plus something times x minus something, because it doesn't have the middle term. I take the square root of 49, which is 7. That was my soccer number in college, by the way. Anyways, so that's like my favorite number. And then for number 3, 4, and 5, maybe pause the video and try those, and I will share those answers with you in a moment. All right, x squared minus 4 would factor to x plus 2, x minus 2. And I just want to note that it doesn't matter if you put the plus or minus first. So for this next one, the square root of 121 is 11. So this would be x minus 11, x plus 11. And I did that leading with the x minus 11 to show you that it doesn't matter the order. And then last, x squared minus 1. The square root of 1 is 1. So this would be x plus 1, x minus 1, or x minus 1 times x plus 1. Okay, remember, you can always check this by multiplying it back out, right? Okay, now that we've done some easier examples, we're going to do some of the more difficult ones that they present to us. So let me scoot over. All right, so one thing that is true about factoring always is that if you can factor out a GCF, you're going to want to do that first, no matter what. So on number 1, I actually have an A here and here. So I need to take that A out because that's the greatest common factor. So I'm going to take out the A, and then I would end up with 36x squared. And then A divided by A is just 1. Okay, so I would have to do that first. And now I have difference of squares. So this piece right here is difference of squares. So I'm going to have the same thing twice. I'm going to drop down my A. I'm going to have a positive and a negative. And because there's a coefficient here, right, like this was 25 and this became 5, I take the square root of that and I get 6x. And then I take the square root of 1, which is 1. And so that's what my answer would look like for number 1. All right, for number 2, I have the difference of squares. It looks a little weird because it's fractions, but that's okay. We don't discriminate against fractions. So I'm going to have a positive and a negative. I need to take the square root of 1/4, the square root of 1 over the square root of 4. The square root of 1 is 1, and the square root of 4 is 2. So this would be 1/2 y, 1/2 y. And then 9 over 25, the square root of 9 over the square root of 25. The square root of 9 is 3, and the square root of 25 is 5. So that would be 3/5. Okay, then we go a little crazy here with 49z to the 8th minus 225x squared. This is the difference of squares, but I'm going to have to do a little bit of work here because when I take the square root of 49z to the 8th, well, 49 will just be 7, right? We know the square root of 49 is 7. But z to the 8th is z 8 times. And because it's a square root, I'm looking for groups of 2. So definitely a 7. And then I would have 1, 2, 3, 4. All right, so what does that mean? Well, that means we're going to have a 7. And then we have z to the 1, 2, 3, 4, z to the 4th power. And that could also be found by taking the exponent on the z right here, which is an 8, right? I could have done 8 divided by 2, since it's a square root, to get that exponent as well. Okay, I just wanted to be dramatic and show you visually what happens. All right, so I'm going to have basically the conjugates, right? And this is going to now be 7z to the 4th here, and 7z to the 4th there. And then I'm going to take the square root of 225x squared. So I know the square root of 225 is 15, and since it's x squared, that would just be 15x, right? Because 15x times 15x would be 225x squared. I will have a positive, I will have a negative. Okay, let's take a look at number 4. So number 4 is the difference of squares. I know I'm going to have one positive and one negative. I know that the square root of 16, that one's kind of easy to do, so I'm going to start with that one. The square root of 16 is 4, right? So I'm going to have a 4 here and here, and that takes care of the square root of 16. Erase that because I'm running out of room. Okay, then I need to take m to the 4th into the 4th and think about if I take the square root of that, what would that equal? So once again, I'm going to show you visually what that would look like. So if I have the square root of m to the 4th into the 4th, I know m to the 4th is actually m times m times m times m. N to the 4th is n, right, times. So I'm looking for groups of 2 because it's a square root. So I would have 1, 2 m's, so m, which would be m squared, and then I would have 1, 2 n's, n, which would be n squared. So that's going to produce m squared, n squared. And a lot of people don't like to do that visually. They like to just look at the exponents and divide them by 2 because it's a square root, right? 4 divided by 2 is 2, 4 divided by 2 is 2. Okay, I just wanted to show you visually what happens. So I'm going to have m squared, n squared, m squared, n squared. Oh, there we go. Okay, so another thing that we have to be able to do is to apply the difference of squares in factor by grouping. That's the ultimate factoring experience. I know you're excited. All right, so we can use the difference of squares in grouping. Here is an example of that. So once again, we're doing factor by grouping. And in our example, you can see that they have grouped the first 2 and the second 2. In the first 2, the GCF is x. So they take out an x. And then they're left with y squared minus 9. In the second group, They don't have anything in common here except for a 1 between these two, right? All they have is a 1 in common, so they take out a 1. And what a surprise, they get y squared minus 9, right? Which is always a good sign when you do factor by grouping and these are a match. So y squared minus 9 goes out. That gets factored out. And then we have x plus 1. But we're not finished because y squared minus 9 itself is the difference of squares. And so we continue to factor. We end up with y plus 3 times y minus 3. And then times x plus 1. So basically, you have to factor and factor and factor and make sure you can't factor any farther before you think you're done. Okay, so let's do a few together. So for number 5, I'll be doing factor by grouping. I'm going to group the first two together and see what they have in common. X squared y minus 4x squared, the GCF is x squared. They both have an x squared in common. When I factor out the x squared, then I do x squared y divided by x squared, which would be only a y left over. And then I do negative 4x squared divided by x squared. The x squareds would cancel out, and I would be left with y minus 4. Okay, for my second group, since this is a minus, I take out a negative. And then the numbers 25 and 100, their greatest common factor is 25. They both have a 25 in common. 25y minus 25 is y. 25y divided by 25 is y. And then 100 divided by 25 is 4. Since this is a plus, I have to change the sign because I had to take out a negative. Now, I'm not surprised that this is a match. That should happen. So I'm able to factor that out. And then I would have x squared minus 25 here and here. Well, I'm not finished because x squared minus 25 itself is the difference of squares. So I can factor that as x plus 5x minus 5. And then the y minus 4 would just drop down. Now I can't do anything else. I'm done. Okay, so let's take a look at number 6. Similar idea. I will do factor by grouping. When I look at this first group, I see that they have an x squared in common. So I'll take out an x squared. And then I'll be left with y squared minus 1 when I take out that x squared. And then for the next group, this is a minus, so I want to make sure to take out a negative. And then for 4y squared plus 4, they have a 4 in common. So I'm going to factor out a 4. When I factor out a 4, I would be left with y squared minus 1. Hooray, that's a match. That gets factored out. And then I'm going to drop down that x squared minus 4. Okay, now this is like the best problem ever, right? Because both of these are difference of squares. So I get to factor both of them. And so the y squared minus 1 is y plus 1, y minus 1. X squared minus 4 is x plus 2, x minus 2. Now I'm done. That was fun. Hopefully this helps.